Hello, welcome to Math with Siddig. This video is mean, median, mode, range, and standard deviation. Although I will say that if you have access to a graphing calculator, to a TI whatever, 83, 84, 84 plus, 85, I don't know if they even make 85s anymore, or some other brand, I would recommend that you do the standard deviation on a calculator if you are in like a testing situation, or if you're in my class currently. I would recommend you learn how to do it on the calculator because it's going to save you time and you have access to the calculator anyway. I'm just going to come up with a set of numbers. I don't know, we'll say, I'm going to stick with kind of small numbers so that I can do most of this in my head or by hand. So all right, so here's my set of numbers. All right, I want to find the mean, the median, the mode, the range, and then the standard deviation of this. So the first thing that you want to do is you want to go ahead and put these in order from least to greatest. And it can be greatest to least, it doesn't really matter. The standard kind of has become least to greatest, which I think is fine. So what I do is I like to look through the list, find the least, write it, and mark off that I've written it. Next. I've got 2 3s, 4, 5, a 6, and a 12. Whew, I might have made an outlier. All right, now mean, which can be represented by x bar if it's a sample, or mu if it's a population, and a lot of times people use them interchangeably, is the average of the data. Most people have found mean before when you talk about like finding your grade on something. That would generally be like, you know, if you have 2 tests, what's the average of the tests? You add together all of the data and you divide it by the size of the data. So this little symbol here means sum. So here you would take the sum of the data and then you would divide by the number of data points or data pieces. Depending on what kind of class you're taking, they might use different words for that. All right, so in this case, we're going to go ahead and add them together. I'm going to add by tens because for me that's going to be easiest in this situation. So 4 and 6 give me 10, 5 and 3 and 2 gives me 10, so that's 20, right? So 20 plus 12 is 32, 33, 34, 35, 36. So this gives me 36 over 8. That's not going to come out evenly, but that's okay. You're allowed to have an approximation. I recommend that you generally go, well, I usually go about 4 decimal places. You don't have to go that many, but I like to go like 4 or 5 decimal places. That way, depending on what the scenario is, I can round accordingly. So if it's something like money, I can round to 2, whereas if it's something where I need to be more precise, I can round it a little bit longer. All right, I don't know 8 into 36 off the top of my head, so I'm going to go ahead and long divide. I believe, if I can still do math, 8 and 4 is 32. Okay, 36 minus 32 is 4. Oh, look it, I'm just fabulous. All right, so my average here is 4.5. All right, so let's say this is something like time spent on homework or time spent studying for a final. So what this says is, on average, kids spend 4.5 hours studying for their final. God, if only that were true. Anyway. Now, the next thing that you can find is the median. Squeaky, squeaky, squeaky. The median is just like the median in a road. It's the center, but it has to be in order. So when the data is in order, can you hear how squeaky that is? I don't know if you can. When data is in order, it's the middle number. If there are 2 medians, take their average or their mean. It's like I have a mouse trapped in my marker. All right, so what I like to do is I have a hard time counting to the middle without marking it. You don't have to mark it, but what I like to do is I'll mark like 1 from each side. Now notice I marked 3 on the left and 3 on the right, and I have 2 middle numbers. So the way that I would find the median is I would take 3 plus 4, which is the middle piece, and divide it by 2, which gives you 7 over 2, which is 3.5. So my middle value is about 3.5. All right, the mode is the number that occurs most. Be careful with this, you could have no mode. So if no number repeats itself, or if every number repeats itself the same number of times, you could have one mode, or you could have several modes. Once it's in order, it's the easiest way to determine it. What you're looking for generally is the number that's going to appear most, or the numbers that appear the most. In this case, my most appearing number is 3, so my mode is 3. For the range tells you, I had a really good word for it earlier today, and I don't know if I can remember it. Oh yeah, I got it. It tells you the spread of the data, and what you want to do is you want to take the max value minus the minimum. What that will tell you is how far apart is your lowest to your highest, so it gives you, like I said, it's the spread of the data. How far apart is the data spread? Doesn't mean it's spread evenly. It just says that the data, the lowest, for example, in this case, the least amount of time a kid spent versus the most amount of time. All right, so in this case, once again, it's in order, so your max should be generally your last number, your min should be your first number. So in this case, 12 minus 1 equals 11. Now, the trick with median and mode is that you can reference what they mean in the scenario. For example, I could say, well, 3.5 hours is the middle number of the data when it's organized. But generally, unless you're looking at a graph and comparing mean, median, and mode to each other, usually mean and median most especially, there's not a whole lot to say. Mode just tells you that the most, more students studied for 3 hours than any other number. And then the range tells you, once again, like I said, there's a 11-hour difference between the least and the most studying, if this was a studying scenario. Now, mean, median, mode, and range are really easy to find by hand, so if that's all you're looking for, I would do it by hand unless it's a really large amount of data. If it's a lot of data, like, I don't know, if bigger than 15 or 20, then you probably would want to do this in a calculator. What I'm going to do now is I'm going to go ahead and erase this, and I'm going to leave the data, and then I'm going to show you how you would find the standard deviation. So I'm going to leave the mean, and I can talk about the difference between these two later. Right now, if you're taking my class, we're not really focusing on that because it's like a miniature statistics lesson. If you're taking an actual statistics class, you would differentiate between these two. All right, so I'm going to go ahead and I'm going to erase this data. Mean is the average, median is the number in the middle after it's in order, mode is the one that occurs most, and the range is the spread of the data, which is max minus min. All right, I'm going to show you how to do this by hand for the standard deviation, but then I'll also let you know if you have a graphing calculator, like generally a Texas Instruments. I haven't really used many of the other ones. I know there's an advanced like Casio, but the only one I've ever really had access to as a teacher and as a student was Texas Instruments, so they've cornered the market. But I'll put in some information about how you could do that in a calculator. There probably is somebody on YouTube who actually has done it with calculator with the screen. I don't even think I brought my graphing calculator home today, so it's not going to be so great for this. All right, standard deviation. And this is just kind of a really basic version of standard deviation because you can use standard deviation to find other things in statistics, but standard deviation tells you how far data expands from the mean, or how far it is from the mean. Maybe I should say how far data is from the mean. The symbol that we generally use for standard deviation is a sigma, and I can't draw sigmas very well, so sorry. Sometimes people will also use S. This usually means population. This usually means sample standard deviation. Right now, for my intents and purposes, there's not going to be a huge difference between them, and I'm going to stick with the sigma. Now, standard deviation is really interesting because what happens is when you find the standard deviation, generally, if it's normally distributed, meaning it's a regular curve, there's not any sort of weird outliers or weird crazy things happening, about 68% of the data will fall within one standard deviation. So here's my middle data. If I add a standard deviation to one part and then subtract it, so if I add it to the mean and then subtract it from the mean, I widen my range of data from the mean to one standard deviation of the mean. Then if I double the standard deviation, I expand it even more. So what happens is about 68% of your data is going to fall within one standard deviation of the mean, if it's normal. If you expand to 2 standard deviations, about 95% of your data will fall within will fall within 2 standard deviations. Now, the trick with that, or why that's important, is generally if you go beyond 2 standard deviations from a mean, you're going to have unusual points or data. So anything beyond 2 is usually unusual. If you do expand, about 99.5% of your data will fall within 3 standard deviations. And that's something that if people are interested, I can do a video on that. I think I'm covering some of that in my class this week for those of you that are with me in class now. But if it's something that you're not in class with me right now and you're interested in, let me know in the comments and I'll talk about it. So how far data is from the mean? Now, to find the standard deviation, you take the sum of the difference between the actual data value minus the mean, or you can think of it as x bar, or you can think of it as mu, okay? And then you divide by n. Sorry, I started thinking about z-scores. Okay, now by hand, this is not that fun because what you do is you have to take the first value minus the mean and then square it, plus the second value minus the mean and then square it, plus the third value minus the mean and then square it. And you continue that all the way up to the last value minus the mean and then squared. Okay, you sum all of those together and then divide by your number of terms, which in this case for us was what, 3, 6, 8? Okay, so it's not something that's particularly fun to do by hand. If you're in a statistics class, you often will do it by hand. If you are in an Algebra 2 class where you have access to a calculator and you're limited on time, it's better to do it in the calculator. Okay, so I can do that out at some point. I don't particularly want to do it out right now because I don't have a calculator with me, and you're going to then have to watch me subtract and then square. All right, but you can find the standard deviation. If you're using a calculator, on your calculator, there's the second button. Below the second button is the alpha button. Next to the alpha button is your xt theta n button, and then next to that is a button marked stat. Okay, almost anything you want to do statistically in a calculator is going to live in this menu. All right, so what you would do to find your standard deviation, and in fact it will help you find your mean, your median, not your mode, but your range, would be in this stat menu. All right, so what you do is you go to your stat menu. The very first thing you're on is edit. So you would hit enter on edit. Okay. Then what happens is it gives you a screen that kind of looks like this. Not LI. You get L1, and it has a line across the top, and L2, and then it should have dotted lines here. You can clear that list by arrowing up to L1, hitting clear, and then arrowing back down. And like I said, it's weird to do this without a calculator. There's probably somebody on YouTube who has done it with a calculator. All right, what you do then is you input your data. So it'll fill in your list. Then you hit the stat button again. You arrow over to calc, and then you hit 1, which is 1 var stats. That just means it's the stats regarding one variable, which is what this is. It's just a single list. It's a single set of data points. It's not something like time and height together, which would be a 2 variable. Once you do that, you get a whole list of things. You get an x bar. I think you get the sum of x. I think they give you the sum of x squared. They give you SX, which is sample standard deviation. They give you standard deviation, so this is your mean. They give you your standard deviation. They give you your how many values you have in your list. They give you your minimum. They give you your Q1. Yeah, Q1. And then they give you median, and then they give you Q3, and then they give you your max. You can use this one for mean. Depending on what class you're taking, you can use either one of these for standard deviation. For me, we're using this one right now because we're going to go population. All right. You can use this one for your median. You can take max x minus min x for your range. The only thing you can't find in the calculator is the mode. Okay, so that was just a real brief calculator overview Okay, for the standard deviation, if you want to see it by hand, like see a full standard deviation problem out, I can do that. All right, but this is just a nice overview. If you're in my class currently, we will talk about this tomorrow, so we can kind of look at the pieces, or in that town, my town tomorrow is Wednesday. If you're not in my class and you just wanted to see a video on mean, median, mode, range, and standard deviation, this is a general one. Like I said, when I was teaching just a pure statistics class, I would have the students do standard deviation by hand to start with, and then once we were past like the standard deviation portion and we were using standard deviation for other things, we always used a calculator, because if you have that as an ability, if you have a calculator in order to do that, I mean, it's just going to save you a lot of time, especially if it's just a part of a bigger problem that you're doing. Okay, where I would head from here is I'd start talking about things like z-scores and probabilities and what these are actually used for in terms of interpreting data. Okay, so hopefully this helps somewhat if you missed this today because of testing, or if you weren't sure about mean, median, mode, range, and standard deviation. If the calculator stuff was unclear, I can go over that more in a video. I've never done a video with calculator before, but I could always set that up somehow, I'm sure. Anyway, have a lovely rest of your day. If you have any questions, comments, you can leave them below. You can always become a subscriber so you can see when I have new math videos, and you can always thumbs this up if you just really love math videos. Anyway, later.